Hey everybody, and welcome to How-To Videos with Dr. Amy Gates. This video is going to explain a process called Hamiltonian apportionment. And apportionment is just a very fancy word that means how to create portions or how to pass out seats or memberships fairly. The word apportionment just comes from the words to portion out or to create portions. And a very common method that's used for apportionment or handing out seats or portions is the Hamiltonian method. And so we are going to review two examples of that here in this how-to video. So why not just divide things out evenly? If you have a bunch of seats that you want to give out in the House or the Senate and you have a bunch of states, why can't you just give the same number to each state? And there's a couple of answers for this. One is they don't always come out evenly. So for example, let's say you have 3 religious groups at a college and each religious group wants to send representatives to a student government. And suppose there's space for 8 representatives at the student government. Now, if each religious group gets 2 representatives, that gives us 6 total, but we still have 2 more spots. But we have 3 religious groups. And as you can imagine, especially with states and Senate and House, everybody wants to send people. So we have to try to figure out a way to fairly decide who gets these extra leftover seats or spaces. And so the Hamilton method is one method for doing this. And it's one method to not only fairly distribute seats or spaces or spots, but also how to give away the remaining or the surplus seats that are left over. Another thing to keep in mind is that not all groups have the same number of members. So in this example, I'm going to do 2 examples here. This is the first one. In this example, we have 3 groups. We have the Christian religious group, the Hindu religious group, and the Jewish religious group. But you'll notice that each group has a different number of members. And it's often argued that the more members a group has, or the larger a state is, the more people it has, and so on, the more representatives it should be able to send to whatever organization it's sending them to. The Hamilton method takes this into account as well. So it's a combination of fairly distributing seats that are available by 2 criteria. One, making sure that it's distributing the seats based on the number of members in the state or in the group and so on. And then the second part is how to give away the extra seats that can't be evenly distributed just based on the number of members. So in this example, again, we have 3 religious groups, and each group has their own number of members. There are 8 seats available that we want to distribute or portion out to these 3 groups. And there are several steps that we're going to take in order to do this. There are a few things that you're going to want to calculate, and the best and easiest way to do this is to create a little table like I've done here. So again, in this case we have 3 groups, but this can be expanded to 100 groups. It doesn't really matter how many, and we know the number of members in each group. The first step is to calculate something that's often referred to as a standard divisor. That's the total population, so the sum of all the people in all the groups, divided by the number of seats you have. So in this case, we have 47 people in the Christian group, 28 people in the Hindu group, 32 people in the Jewish group. We add all those people together to give us our total population, and we divide it by the number of seats that are available. Remember, we said that we have 8 seats available in this example. And when we add these together and divide by 8, we get 13.375. Be careful with your rounding. Keep at least 3 significant digits when you're doing these problems. So this is called the standard divisor. And we're going to take this value and we're going to use it to then calculate what's called the standard quota, which is also often referred to as the average constituency. In other words, the basic number of seats that we can give out before we start considering things like surplus. So here's how that works. Again, when we got the standard divisor, we took everyone in the population, all these people, divided by the number of seats we have, and we got this value of 13.375. Now what we're going to do to get the standard quota, which is also the average constituency, is we're going to take each individual group. So in this case, the religious groups. So each individual group will get divided by that standard divisor. And we'll come up with a decimal value. And again, it's best to keep at least 3 significant digits on your decimal value. So when we do the division for the Christian group, we get 3.514. When they do the division for the Hindu group, we get 2.093. Notice that we divided 28 by the standard divisor. And for the Jewish group, we divided 32 by the standard divisor and got 2.393. The next step is to determine the basic number of seats that we can easily pass out without worrying about surplus or what to do with these fractional portions. That's a simple step because all we do is round down, always down to the nearest whole number. So it doesn't matter how big the decimal is. This isn't normal rounding. It's called rounding down. So 3 point whatever becomes 3. 2 point whatever becomes 2. And 2 point whatever becomes 2. So these are the basic seats that we can easily give out. And it's not surprising because our Christian group is the largest. So it so far has the most number of seats. The other two groups are fairly close, though you can see by the decimal values that they're not the same. But either way, their whole number is represented by a 2, and that's how many seats they get so far. Now at this point, we've given out 3 plus 2 is 5, plus 2 more is 7. We've given out 7 of our seats, but we have 8 seats. So in this case, how do we give out that last seat? That's the next question we have to answer. And it's actually a very straightforward solution. That remaining seat is often referred to as the surplus or the leftover seats that we couldn't evenly distribute by dividing by the special number we calculated. So the next thing we do is we look at the leftover decimal value, and let me highlight that better. Here it is. We look at the leftover decimal value for each of these groups. In this case, we only have 1 extra seat, so we're going to find the largest leftover decimal value, and that's the group that's going to get the extra seat. And if you think about it logically, that makes sense because they were the closest to qualifying for that extra seat. So here's what that looks like in the end. We've compared all of our decimal values. We've concluded that the 0.514 is the largest of all the decimal values. It has nothing to do with this value. We're only looking at the decimal portions. And because of that, we agreed that the extra seat goes to the group with the largest decimal leftover value. And so they end up getting 4 seats. And that's our total and final answer. We give out 4 seats to the first group, 2 to the second, and 2 to the third, for a total of 8 groups. Well, let's do another example of this now. In this second example, suppose we have 4 groups, and they're political groups. And each wants seats in the University Student Government Committee, and there are 25 seats available. Here's our groups, and here's the number of members in each group. So we have our Republicans with 349 members, Democrats with 471 members, Independents with 283 members, and Humanitarians with 129 members. We know logically that the larger the group, the more seats they're going to get. But in order to determine exactly how to distribute those seats, our first step is always to calculate the standard divisor. And the standard divisor is the total population. That's the sum of all the people in all the groups, so we're going to add all of those up, divided by the number of seats that are available. In this case, we have 25 seats. So when we add up all the people in all of our group, all of our 4 groups, I should say, we have 1,232 people, and the number of seats available is 25. When we do the division, we get 49.28 as our standard divisor. Again, retain decimal values when you do these problems. So this is the number that we're going to use to divide each of these individual groups by to get the basic number of seats that they automatically earn, and then also to look at the decimal leftovers to decide what to do with any surplus. Okay, so again, we take this divisor and we divide first the number of Republicans by that divisor. That gives us 7.082. Then we divide the number of Democrats by that exact same divisor, 9.558. We do independents by the same divisor. We do humanitarians by the same divisor. Our first step is always to look at this whole value. That's a 7. This whole value is a 9, and so on and so forth. In other words, we round down whatever value we get to determine the exact number of seats that we know each group is going to get for sure, before we then decide how to divvy out the leftover seats. So the Republicans get their 7 seats, Democrats get 9, the Independents get 5, and the Humanitarians get 2. We don't look at the decimal portions at all when we do this. That's called rounding down. Do not get confused and attempt to round up, thinking, oh, well, this is a 7, so I need to round up. That would be an incorrect step at this point. At this point, we just look at the whole numbers. It's called rounding down, and those are the values we know so far we are going to give out as seats. Now, what's the sum of the seats we've given out so far? 7 plus 9 is 16, another 5 is 21, and 2 extra is 23. So we've given out 23 seats so far, but we have 25 total to give out. And so because of that, we actually have 2 seats left in our surplus. And we have to decide who gets those last 2 seats. The way that we do this is we compare only the decimal portions. The largest decimal portion gets the first of the 2 seats. The second largest decimal portion gets the next one. So looking here, we can see that the 0.743 is the largest decimal portion. Don't worry about the 5 or the 9 or the 7. We're only looking at the decimal portions. This is the biggest one. The second biggest one is below it, the 0.618. These 2 decimal portions are smaller. So the Independents and the Humanitarians are each going to get one of these extra seats because their 2 decimal portions are the largest, and we have 2 seats left. If we only had 1 seat left, the Independents would get it because they have the largest decimal portion. But since we have 2, we just go in order, handing those seats out to whatever group has the largest decimal portion. Now, there are some exceptions here that I want to talk about briefly. Let's say that one of these groups was super tiny and actually had no seats at all, but we had at least 1 seat in surplus. We could give that extra seat to a group that had absolutely no seats, and that is certainly an option of this method. That does not apply here because all of our groups have at least 1 seat. And so when we hand out those 2 surplus seats, we hand out the first one to the Independents, we hand out the second one to the Humanitarians. And when we do that, we can double check our total. In the end, we've given out 7 and 9 is 16, and 6 is 22, and 3 is 25 seats, and that's exactly what we wanted to do. So these are 2 examples of the Hamiltonian method for apportionment. And in the final conclusion of what we just talked about, remember that the group that had 5 seats, which was the Independents, actually had the largest decimal value. This is maybe the biggest point of difficulty or confusion with these types of examples. So remember, you have 2 separate steps here. Let's review just quickly. When you give out your initial seats, you look at the whole numbers only, and you don't look at the decimals at all. So 7, 9, 5, and 2, they carried over. But we had 2 seats left over. So we need to then look at the decimal portions only, choosing the 2 largest. This was the decimal portion here, and the second largest was below it. And that's why we ended up giving out our extra 2 seats to those 2 groups. All right, I hope this helped with apportionment, and thank you for joining me.